Hello, everybody. This is Sharon Fisher from Teledyne ISCO's marketing department, and we are happy to offer this webinar today in regards to Teledyne Valeport Water flow products, which we will now be offering. Today, we are being joined by Matt Brownhill, our UK country manager, and Cashel Taverdi, who is our associate director of ISCO Water products. I would like to start off by reminding you of a few details. If you happen to have any questions, please utilize the questions function within GoToWebinar. These questions will be answered at the end. If you're having any audio or video issues, please be sure to leave the webinar and rejoin. This oftentimes will clear these issues for you. With that, I would like to turn it over to Cashel.
Hello, everyone. I'm Kaushal Trivedi, Associate Director, Business Development for Teledyne ISCO Water. Those who don't know, Teledyne ISCO was established in 1958. We are a US-based company located in Lincoln, Nebraska. Teledyne Water is in market for open channel flow meter and automatic samplers. We are a vertically integrated company and provide complete end-to-end solution for measurement to remote communication and cloud-based data storage and analysis. Thank you all for joining the webinar today. We are excited to present products from our sister company, Teledyne Valeport. Little background on Teledyne Valeport. Teledyne Valeport is a UK-based company. The company was established in 1969 and serving water, wastewater, oceanography, hydrographic, and hydrometric communities worldwide for more than half a century. Teledyne ISCO Water will distribute some of their water and wastewater products. In the first phase, we will introduce two products, Insertion Magnetic Flow Meter Model 804 and Handheld Current Meter 801. With the Insertion Magnetic Flow Meter, Teledyne ISCO Water will re-enter into full bore or closed pipe flow measurement. I would like to invite Matt Brownhill, our UK Regional Manager, to present these two Valeport products that will be distributed by Teledyne ISCO. Matt, you're welcome.
Thank you, Kaushal. So yeah, my name's Matt Brownhill. I've been with Teledyne ISCO for about 5 years now, and I'm the UK Regional Manager. As Kaushal mentioned, we are focusing today on two key products that enhance Teledyne ISCO's product portfolio. The Type 801 handheld velocity current meter, but first up I will be speaking about the Type 804, which is an insertion magnetic flow meter. So the sensor has three measurement points. The tip has a velocity and a temperature sensor, and in addition to this we have an optional external pressure connection, which is located just above the tip there. So the principle of operation for the velocity measurement. So the sensor adopts Faraday's principle to read velocity. The sensor creates a magnetic field and an EMF voltage. It's then generated that's proportional to the velocity of the conductor. In this case, water is the conductor. The sensor is inserted into the pipeline, either at the center point or at a 1/8 diameter depth. This all depends on the application and the site specifics. Flow is then calculated from the velocity reading. So we use a formula to calculate the flow rate. The formula is K multiplied by A multiplied by V. So K is the constant. This is determined by multiple factors such as the insertion depth, the pipe size, the pipe shape, and the constant is generated via the software used when programming and commissioning the unit. A is the area, the internal cross-sectional area of the pipe. This is calculated from the pipe shape and the pipe diameter. V is the velocity measurement that is being measured by the sensor itself. And then flow rate, Q, is then calculated and recorded by multiplying the constant, the area, and the velocity. So I'll go through the different parts of the Type 804 sensor. So first up, you have the alignment spar, which is located right at the top. This can be used to align the sensor to be in line with the oncoming flow in the pipe. A safety chain is installed to prevent the sensor from being ejected from the pipe. This can cause damage to the sensor, or in a worst case, it could cause injury to the operators. So always use the safety chain. There's a pressure coupling. So this is external and it sits outside the pipe. It enables the hydraulic pressures to be measured by an independent sensor if applicable. The sensor is the small black bit at the end with the circle on there. So this is the electromagnetic sensor that is inserted into the pipe. At the top, you have the electronics, all located in the IP68 housing at the opposite end of the insertion rod. Then the connector, which can be used for external power and also for commissioning and programming the unit, in addition to downloading the data to laptops. Then a bit further down the rod, you have the insertion marker. This is used to measure the correct insertion length for when you're putting it into the pipe. And then down at the bottom, you have a clamp ring. This is used to tighten against the insertion marker to ensure that the sensor remains at the correct depth inside the pipe. So here's an example drawing of the sensor installed. You can see that the brass clamp ring is tight against the insertion marker. The safety chain is in place and the sensor has been inserted into the pipe with everything else remaining external to the channel. Another example here of how to install the sensor. So first up, you carefully slide the sensor tip to touch the ball valve that is installed on the pipe. You then move the insertion marker to the set insertion length. So this should be the length of half the pipe diameter between the clamp ring and the insertion marker, assuming that you are installing it in the center of the pipe. Then you tighten the marker in place, and then you begin to slowly insert the sensor into the pipe until the clamp ring meets the insertion marker. Once they meet together, you can then tighten the ring to keep it in place, and then you align the sensor using the alignment spar on top of the IP enclosure. Once that's done, you secure it with the safety chain, and then consider if you are installing at the 1/8 of the depth that you need to perform the steps above, but the initial step in number 2 is calculated accordingly with the pipe diameters. So the insertion marker would be a bit lower down, and then you'd clamp it into a different position on the pipe depending on how far into the channel that you need to insert it. So there's some considerations for the installation, the position in the pipe. So the sensor should always maintain the center line of the pipe. Even if you have to offset it, as you can see in that top image, always follow the diameter. The second image there, you can see with the red X, it shows that the sensor has been installed off the diameter line. This is incorrect, and the readings, you will get unstable readings of velocity in that situation. So always follow the center line through. Other considerations are obstructions upstream and downstream. As with many velocity measurement sensors, we need to consider both upstream and downstream obstructions. Downstream of the sensor in this application, in this sensor, is generally 5 times the pipe diameters. Upstream does need further consideration, and it all depends on the application that you have. So there's a table there shown on the right hand side, shows the half diameter insertion diameters required. So ideally you want to be 25 diameters away from a 90-degree bend, for example, or 15 diameters away from a fully open gate valve. If you're installing at the 8th depth in the channel, the upstream requirements increase, and in some cases they can more than double the approach length. So all of this needs to be considered when installing the sensor in the correct location. So moving on to the power options available to us. This shows the internals of the 804 when we're using the standard battery-powered configuration. And slightly different, this is an external powered version. So having the two different options, it does provide us with flexibility to the user. The unit is extremely low powered with a typical battery life of around 4 years. The battery version uses two 19 amp hour lithium batteries. And we also have analog and digital outputs available with open protocols that are compatible with many third-party loggers and SCADA or data acquisition systems. So this slide will summarize the sensor specifications. We offer two insertion lengths, 12 inches or 20 inches. This enables installs in pipes ranging from around 4 inches all the way up to 80 inches. The velocity measurement range is 0.07 feet per second up to 16 feet per second. And we have an accuracy of plus or minus 2%. The sensor also has bidirectional flow capabilities, and it can be recorded to display the net totals. So if you do have reverse flows coming, the total volume will show the net total that's gone through the pipe or back up of the pipe. There's also a inbuilt temperature sensor and the optional pressure sensor coupling just above the tip. So the benefits of using the 804 is it's lower cost than an inline flow meter such as a mag flow meter, especially in larger diameter pipes. There's lower installation costs. It's a hot tap type installation, so you don't cut a section of the pipe out to install it. This means that you don't have to stop the flows, you don't have to empty the pipe or divert the flows or overpump or anything like that. Again, the cost implications, particularly in larger pipes for mag meters installations, can be extremely expensive. Lower maintenance costs. So some issues that you can see with inline flow meters is liner leakage, for example. The removal of the sensor is easy as well. It's carried out in live flow conditions, and in most cases, it just requires a sensor clean. Many inline flow meters require calibrations back at base, so you have to remove it from the line, send it back to the factory, which then introduces all of the installation headaches that I've mentioned above. With this system, it's just remove it and reinstall it. So if you did need to put in a secondary sensor whilst that one goes back to a factory for calibration, you can just slide the new sensor straight back into the line. And it also comes with a factory 3 years warranty as standard. The approvals that are with the sensor, so the unit is NSF certified and uses WRAS approved materials. This means that it can be used in all drinking water applications. On the right hand side, you can see that there's the water ingress certificate shown, which rates the IP rating at submersible for 5 feet for a duration of about 100 hours. So I'll go into some applications, some examples that you can install. So there's metering at reservoirs. So utilising the battery power option in these remote locations, you don't need to feed any mains power to the unit. You've got a 4 years battery life, so it's ideal for those remote locations. There's water treatment plants, so these often have large pipes, and going back to the installations on inline meters, this can be a much more cost-effective solution. And then pumping stations, so you'll have pump flows, usually have mains power available on these types of sites, so an external power option would be suitable. But again, you don't need to be cutting into the pipe, you can just install it straight into the pumped flows. Another example is DMA, district metered area. So these types of areas typically have a low nightly flow, limited space, usually inside a manhole with a pipe running through. Again, it's an easy application, an easy installation even. You just slide it into the pipe using the non-return valves. Power efficient, so the battery option, you install it, you don't need to run mains power there, it will log through around 4 years. Easy maintenance, remove it, clean it, insert a new sensor if this one needs to go back to the factory. The controller, the enclosure, it's IP68 rated, protects in the event of a flooding. So if the pipe did split for any reason, it's protected by the enclosure. And then the open protocol as well, as in this application here, there's a manhole chamber. If you can pull the data out to a SCADA or data acquisition system, it removes the need to enter that confined space to download the data. Can also be used for non-revenue water or leak detection. So non-revenue water is water that is lost before it reaches the customer, and this is a huge problem. So most water utilities lose around 20% of the water as NRW. And in 2007, the EPA estimated 1.7 trillion gallons of water was being lost per year, which is the equivalent to around $2.6 billion. So it's a big problem. Other applications include cooling towers, boiler feeds, effluent flow, screened wastewater, irrigation water. You'll note there that I have mentioned effluent and wastewater. I would say that considerations do need to be accounted for, such as rags, fats, solids, any other debris. The 804 should only really be installed post filters when you're going into these types of applications. You won't damage the sensor, but any rags going over the sensor, fats coating it and things like that, it's just going to increase the maintenance that's required on the sensor because it does sit intrusive in the pipe. So always go post screens, post filters. So that's the 804. I'll move on now to the 801, which is a handheld current meter. So the 801 system is made up of the following components. So you have modular wading rods. These are for measuring the different depths of the water. So the rods are around 20 inches in length, and they have half-inch increments so that the sensor can be positioned accordingly in the channel or the river. There's two base options available. So we have a flat disc, usually used in man-made channels, which are nice and flat. Or we have the pointed tip. So this would enable you to dig the base into a riverbed or stream bed, so you can hold it in place more securely. At the top of the wading rods, you then have the directional knob. This is similar to the alignment spar that I mentioned on the 804. It enables you to point the sensor into the oncoming flow. It also features a spirit level, so you can ensure that the sensor is in an horizontal position. Then we have the controller with an LCD display. Live readings can be shown. This also has data storage capabilities, which can be set and programmed to different logging rates. The controller comes with a shoulder strap, so if you're wading in the river, you don't have many hands to hold everything with. This can sit over your shoulder, so then you can have both hands on the wading rods. And then all of the items, they come delivered in a purpose-built pelly case. This is easy for transportation and obviously storage. It all goes back in the box and on the shelf. The principle of the operation is the same as the 804. It adopts Faraday's principle, although this is a velocity-only measurement. The sensor can be positioned at the desired location with the wading rod increments. You can see the increments there on that drawing. So each one of those is ½ an inch, and you can just raise or lower the sensor accordingly and tighten it back into position. And then the sensor should always flow, so point the direction of the incoming flow. So onto the features of the 801. It's a maintenance-free sensor. Just wipe it clean, put it back in the box, and it's ready for next time. It has a velocity range of minus 16.4 to positive 16.4 feet per second. The accuracy is plus or minus 0.5%. The minimum depth of water required for the operation is 2 inches. The wading rods, as mentioned, are modular. They have threaded ends to adjust the height accordingly, and you can keep connecting these to the desired length. The controller, it's easy to program. It has onboard data storage. It also has it's handheld. It displays the live readings if you don't need to data storage. If you're just looking for spot readings, it's got that display on there as well. And it comes in 2 different cable lengths. So you've got a 6-foot cable length, which is for measuring velocity whilst you're standing in the channel, so such as a shallow river or a stream if you're wading through it. Or we have the 20-foot cable length, which is more for when you're taking readings off of a bridge or maybe above a ground sewer in a manhole or something like that. So you've got the wading rods and the extra cable length to reach down to the water. So the applications, 2 main applications are river profiling and velocity cross checks. Speaking about the velocity cross checks, so many sensors that do measure velocity, they can't be field calibrated, so you can check the depth quite easily with a ruler or something like that. But the velocity you can't really check. So the 801 provides that cross check. You can dip it into the same channel, and you can get that cross check of velocity and check it against the installed instrument that you've got on site already. I think that is the last slide. Yes. So that's the end of the presentation. So what I will do now is I will pass it back over to Kaushal, who I believe is going to handle any questions that have come in during the presentation. So thank you.
Thank you, Matt. Nice presentations on these 2 products. Please, if you have any questions, please send them through the question section or the chat sections, and we will answer them if the time runs out, and if we cannot answer all the questions, we will answer them later on. So I started getting questions already. The first questions is, what external power voltage can be used on the 804? I think you are talking about external power version, because we have 2 models. One is the battery powered and another one is external powered. For external power, you can use 12 to 28 volt DC external power. There are sub questions to that is, does it require a dedicated power supply, or it can be powered by a logger that it connected to? There is no need for dedicated supply. You can power it with a logger that you are connecting. If it has a anywhere between 12 to 20 volt DC power output, yes, you can connect to that power. Second question came in that you mentioned that 804 battery powered version has using a lithium battery. Can you specify what kind of a technology it is, and is it rechargeable or not? So we are using lithium thionyl chloride batteries inside, 2 batteries you have seen. And this technology provide an exceptional battery life even during low temperature. That's why we picked that. and hence it's very good for remote location. So if you're a remote location, you don't want to visit that site quite often to change the batteries. That's why we picked this, which is having a longer battery life even the temperature is low. And no, they are not rechargeable. They are primary cell, so you have to replace them uh, when it is discharged at that time. Next question is, what outputs are available on the 804, which is insertion magnetic flow meter? The unit has two output, pulse output, or you could call it the frequency output, pulse output, whatever you call, as well as Modbus outputs. That's why, with the Modbus is a universal output, so you can connect to any of your logging device. It has, connectivity that way. So there are the two kind of an outputs available, pulse and Modbus. Next question is, how do you program the 804? It is programmed through a software, and software is available on our website for a free download. And it, as Matt explained to you, that it allows you to do a lot of things, including calculating. It calculates the constant itself. We have seen that many of competitor products, they do not allow you to find out the coefficients, and you have to take their supports. This software is so intuitive that it will provide all that information you require to program the meter at site. The next question is, how's 801 is powered, or the same kind of stuff. So the 801 is powered by 8 alkaline C cells. So there's an internal, so we provide those battery in the beginning, but there are C cell and there are alkaline C cells. And battery life is around roughly 37 hours of operation. So it should allow you to complete any of the temporary flow studies or velocity current measurement studies and those kind of things. It will allow you to do that. The next question is, what is the maximum welding rod length for the 804? The welding rods are mechanical items, which does not affect the performance, just to be clear in the beginning. So it's not a performance issue, but the limitation will come from the cable length. As Matt explained, that we are offering two versions. One is with a 2 meter and second is 6 meter. So maximum length is 6 meters. So as long as the electronics unit is within that reach, you're fine. Word of caution though, if the velocity is very high, you will have to fight against that high current. In the high flow application, you try to rest your welding rods at the bottom, and you have to fight against that. That's a caution, but otherwise you can go as long as you want. As far as electronics, the cable length is able to reach to the electronics. So what I mean is, if you put your sensor, let's say more than 6 meter deep, but your sensor is on the top, yeah, you can do it, but you will have to struggle to hold that welding rod in the pipe or in the channel. The next question is, how can I get prices for these products? Please contact your local Teledyne ISCO rep or distributor, and they will be able to help you. They have all price informations, and they will discuss with you your requirement and try to meet your application needs and try to quote you accordingly. I don't see any more question, but as I said, if you have any more questions, feel free to contact us, and you can send through the chat or the question section here, or you can send it via email. So feel free to send us the questions. We are happy to answer them. Thank you very much.
Well, thank you, Cashel and Matt, for sharing all of this information about the Valeport products. We are very excited that we'll be offering these now. If your question was not answered, we will respond via email. If you didn't have the opportunity to view this in its entirety, you will be receiving a YouTube invite, and then you can watch it on YouTube as many times as you care to. Thank you so much for joining us, and we hope to see you again soon. Thank you.